Hi, I'm Dylan and I worked on the Pantry recipe app with Tim and Meera. For our project, we decided to tackle the problem that cooking every day can create, and that's being a chore, especially when you're not sure what you can make with what you already have. The solution, we created the Pantry, a recipe finding app. You can search ingredients you already have, and a list of recipes with these ingredients will be returned, or try a random recipe generator if you want to try something new. From start to finish of the project, agile software practices and strong team working were key in making sure the project moved as smoothly as possible in a cohesive manner. For example, Kanban boards, Trello and Miro were used early on to brainstorm the initial idea, make sure we had a minimum viable product and allocate tasks to each other, making sure the project was constantly moving. We used Canva early on for layout and design of the project, looking at where components can go and where logos can go. We used Slack to organise bi-weekly meetings and paired that with mob programming to make sure we were bouncing ideas off each other, and if one of us was struggling, someone else could help or offer a hand. It also proved great at showing new ideas we were coming up with throughout the process. Let's take a look at our early brainstorming process. In the very infancy of our project, we used Miro to brainstorm our ideas. Here you can see we broke it down into categories: must-haves, should-haves, and could-haves. This allowed us to generate a minimum viable product that we wanted to present to you guys, and also allowed us to throw all our ideas into one pot, remove what might be a bit unnecessary or a little bit beyond our scope, and keep the core ideas of our projects. Once our initial brainstorming was complete with Miro, we migrated that across to a Trello board. This allowed us to create key card tasks, which we could delegate to one another, allowed us to track how we were doing with the tasks, and also add further tasks as we moved along. This proved invaluable for keeping our project on track, in time, and making sure that our minimum viable product was done, and that if we could, we knew what we needed to add. Here you can see the tech stack we used to build my Pantry. For the front end, we used React and React Router. This allowed us to view changes live and allowed us to address any errors as they came up there and then. Sass was used for styling. This kept all our components uniform, colors uniform, and just enabled us to have a more coherent style across the project. JavaScript was the language we used, and Axios was the library we used to communicate with the backend API. Testing was done with Jest and React Testing Library. For the backend, Node.js was used, Firebase was used for authorization, and Postman proved invaluable when we had issues with our API requests. Now guys, I'll pass you over to Tim to take a deeper look at the code and my Pantry.
Hi, my name's Tim and I'll be taking you through the app that we've built and also some of the code. This is the landing page. It's the first page the users will see when they load up our app. You click enter and you're taken through to a login page. This is where you can log in, create an account, or also continue as a guest. We used Firebase for the authentication, and also we set up some protected routes, so if the user tried to amend the URL to show the My Account page, if they weren't logged in, then they just get redirected back to the home page. So once you've logged in, you'll be shown this page, which is the recipe form. Find a page. This is where you can search for ingredients, change the cuisine, select any intolerances, and select a maximum cooking time if you want to. So if we were to search for chicken, change the cuisine to Italian, the intolerances, say dairy, the maximum cooking time is 60 minutes. You can hit search, and we can see from the toast that it's found some recipes. It's found 3 recipes. If you click on a recipe, it will automatically scroll down using the useref hook, and you can see it shows the recipe title, image, the ingredients that you entered, any missing ingredients, and the instructions. You can also select save, which will save the recipe to your account. That will save in Firestore against your unique user ID. Here you can see the saved recipes, so you can click on one, again it will scroll down, it shows you the same information as before, but also now has a star rating addition, so you can click here, you can rate the recipe, that will update the document in the collection and will remain persistent when reloading the page. Here you can also add a recipe, so you can add your own recipes if you want to. So you put in a title, you can add your ingredients, you click add, you save those. Same with the instructions. You go into how long it takes to cook, and then you can add the recipe, it resets the page for you, and then you can see here that this test recipe is loaded here and it shows you that information. Here's the code for the recipe find form, and this is where it shows the submission and the API call. So here we've got the standard API that includes the ingredients from the ingredient search. It shows that we've asked for a maximum of 50 results, and we're ignoring Pantry items, so things that would ordinarily be in a cupboard. Then if the cuisine type is true, or cooking time, or intolerances, then they will also get appended to the API endpoint, and those get set by onChange functions. In the My Account page, we have a few different calls to our database where we can get user favorites. So we do a get request to the recipes collection. For each document there, we check if the unique identifier for each document matches the user's unique identifier, and if it does, then we return those to the page. Similar thing with the user recipes, where we instead get the documents from the user recipes, and of each one we check the same thing. And if they are truthy, then we also put those onto the page.
Hi, my name is Meera, and I'll be going through the last part of our presentation. So Tim already went through some of the code on the recipe finder form and the My Accounts page, and I'll be going through the Add Recipe form. So this form allows the user to enter their own ingredients and instructions into their recipe so they can save that to their account. We use various use states, which is where the information is stored that the user types into the form. Once they are finished and they save the form, we use the handle add recipe handler. So this information is stored in our database under the user ID, so they can then access it on their My Accounts page. So for our navigation bar, we use navlink and link from React Router DOM. We created buttons so that when the user clicks on the button, a different component would be rendered depending on the endpoints listed. A full list of our endpoints are in our app.js. We also created a hamburger navigation bar so that when the screen size is smaller, below 768 pixels, they would have a drop-down navigation bar instead of a horizontal navigation bar, just for aesthetics and ease of use. So for our styling, we use Sass styling. We created a variables.scss file where we defined all our colors, font family, font weight, rate point, spacing, and max width. These are then referenced in our functions file, which we then use in each individual component file. So if we have a look at one of our style components, you can see how we've referenced the different spacing and colors. This means that our styling is consistent and uniform throughout, and the color scheme will not be altered. Though we had a few issues initially when working on the project. Initially, we started off working using the edamame API, but as we started writing our components and making API requests, we realized that it didn't have all the endpoints we needed. So we ended up having to change the MPI to Spoonacular, which wasn't too bad. It just meant that we had to rewrite the Axios requests that we had and change the API key. We also had some issues using GitHub together on one repo. It got confusing at times when we were all trying to push and pull the same code. There were points where we accidentally wrote over new code with old code, and when we had merge conflicts, it took some time to resolve them. But once we got into the habit of telling each other on Slack when we were pushing new code and making sure we all pulled the new and current code before working, that helped to avoid these issues. Also, when trying the new code, we had to make sure we didn't push this code if it wasn't working to the repo, or that we commented it out before pushing. This helped us to stop breaking any existing working components. The most difficult concept we had to work on was to filter the API results. We weren't initially sure how to do this, whether we should store all the return results from the existing Axios request and then filter through those, or to make a new separate Axios request underneath the existing one, neither of which seemed like a good idea and would just make our app slower. So we finally ended up just making an addition to our existing API request by storing all the different filters inside queries and saving those to separate variables. So then if the user selected any filter from the list, the query would then be added to the end of the existing Axios request. So this saved us making separate requests for each filter. Also, in the Add Your Own Recipe page, we wanted to change the color of the ingredients or instructions once they were saved from red to green, just to make it more obvious and user-friendly. This was more complex than we initially thought it would be and required using state and saving the number of ingredients and instructions within this. Then for each separate button, we had to write a function which either returned green if there was something saved in the state or red if not. So if we had more time, there are some changes we would have made. We would have added further styling, mainly media queries to our design to make it more responsive. Currently, it is only designed mainly for a laptop screen and a smaller mobile size screen, but we would have wanted to have various responsive designs for different screen sizes. Also, on the landing page, we would have removed the navigation bar as it really isn't needed there. But since the landing page was only added later, we would need to have changed the layout of the code as we currently have it. We could have also added further login options, allowing users to log in, for example, with their Gmail account or any other social media account to save them having to create an account if they don't want to. Also allowing users to toggle the visibility of the passwords so they can see what passwords they are typing in. If we had more time, we could have also allowed the user to use an image of their choice to appear next to a recipe they had written, so they could upload their own images. Currently, there is a default image provided for each recipe. So that takes us to the end of our presentation. We would like to thank everyone at Command Shift and all the tutors who have helped us and supported us through the course in completing our final projects. If you want to contact us, you can find our GitHub and LinkedIn accounts on the screen. Thank you.